problem is continuation of the model 1 of fluid mechanics. Okay, so the problem is calculate the dynamic viscosity of an oil which is used for the lubricating between a square plate of size zero point 0.8 meters by zero point 0.8 meters and an inclined plate with the angle of inclination 30 degree. As shown, the weight of the square plate is 300 Newton and its sides and which slides down the inclined plane with a uniform velocity of 0.3 meters per second. The thickness of the oil film is 1.5 mm. So here they are going, there is inclined, there is a plate which is placed at the inclined at 30 degrees and its weight is 300 Newton and initial velocity u is equal to 0.3 meters per second and it is a oil of specificity which has been used. Okay, so given area equal to zero point 0.8 into zero point 0.8 that is equal to 0.64 square meters, theta is 30 degree and weight is 300 Newton. Initial velocity u is equal to 0.3 meters per second. Therefore, divide the 1.5 into 10 to the minus 3 meter. Therefore, component of the weight W along the plane is equal to, so vertically and that is W into cos theta. So we have resolved this into vertical component, that is W into cos theta, that is 3 and W is equal to 300 into cos 60, that is 150 Newton. And we know that tau is equal to force upon area, that is 150 divided by 0, area is 0.6, that is 234.375 Newton per square meter. And tau is equal to mu into dou U by dou M, that is equal to mu they are gone to, that is 2 are going to 234.375 minus of mu, that is equal to mu is equal to mu into 0.3 divided by 1.5 into 10 raised to minus 3. Therefore, mu equal to 1.7 into 10 to 1.7 Newton centimeter per square meter, or mu equal to 1.17 into 10, that is equal to 11.75 or 11.7 twice. Similarly, next problem, the dynamic viscosity of an oil used for lubricating between a shaft and the sleeve is 6 poise. The shaft is of diameter 0.4 meters and rotates at 190 rpm. Calculate the power lost in the bearing for a sleeve length of 90 mm. The thickness of the oil of the film is 1.5 mm. So mu equal to 6 pi, that is 6 divided by 10, that is Newton centimeter per square meters. So we counted poise into Newton centimeter per square meters, and D they are again 0.4, n is equal to 190 rpm rotation per minute. They asked you to find the p value, how much. L they are given 90 into 10 raised to minus 3 meters, and dy they are given 1.5 into 10 raised to minus 3 meters. We know that u equal to pi dn upon 60. So pi into diameter 0.4, number of rotations 190 divided by 60 seconds, that is 3.98 meters per second. And we also know 2 is equal to mu into dou e per dou m, that is equal to 6 divided by 10 into 3.98 divided by 1.5 to 10 raised to minus 10, that is equal to 1.159 Newton per square meters. Then 2 is that is 2, C stress 2 is equal to force upon area, that is 4 divided by area is pi into d into L. Therefore, force divided by pi into 4 into 90 into 10 raised to minus 3, that is equal to 1.592. Therefore, F is equal to 180.05 Newton. Therefore, power loss to the F is equal to F into that is equal to 180.05 into 3.99, that is equal to 716.48 watts. Next one, a vertical cylinder of diameter 180 mm rotates concentrically inside another cylinder of diameter 181.2 mm. Both the cylinders are 300 mm high. The space between the cylinder is filled with liquid whose viscosity is unknown. Determine the viscosity of the fluid if a torque of 20 Newton meter is required to rotate the inner cylinder at 120 rpm. So diameter of inside is equal to 180 into 10 to the minus 3 meters. Diameter of outside is equal to 181.2 into 10 to the minus 3 meters. Length is equal to 310 to the minus 3 meters. Then T equal to 20 Newton meter. N is equal to 120 rpm. Therefore, 2 equal to mu into 2 upon 2, that is force upon area, that is equal to mu into 2 upon 2. Then U equal to 5 dn upon 60, that is 5 into 1 8 10 10 10 to minus 3 into 120 divided by 60, that is equal to 1.13 meters per second. Okay. Next one, a vertical gap of 2.2 centimeter wide of any initiate extent contains a fluid of viscosity 2 newtons second per square meters and S is equal to 0.9. A metallic plate of 1.2 meter by 1.2 meter into 0.2 centimeter is to be filled with the constant velocity of 0.15 meters per second through a gap. If the plate is in the middle of the gap, find the force required if the weight of the plate is 40 Newton. Therefore, there is a plate, okay, of 1.2 by 1.2 by 0.2 centimeters, okay, hole. Then here mu is given 2 Newton centimeters per square meters. S is equal to 0.9 meters. W weight is equal to 40 newtons and the initial velocity is equal to 0.15 meters per second. So you can see the dimension of that plate, that is 2.2 into 10 to the minus 2 meters. Okay. Therefore, we know that dou equal to mu into dou u by dou y. That will be given as from the basic examples, that is mu equal to dou u by dou y. Therefore, we can have the above calculation, that is as given below. Therefore, the plate is in the middle of the vertical gap. Therefore, the distance from the vertical surface to the plate on the left side is equal to 1 into 10 raised to minus 2 meters. Therefore, the right side is equal to 1 into 10 raised to minus 2 meters. The shear stress on the left side of the plate is tau equal to F upon A, that is equal to mu into tau U by tau F. Therefore, F1 is equal to 2 into 0.15 divided by 1.0 into 10 raised to minus 2 into 1.2 into 1.2, that is equal to F1 equal to 43.2 Newton. Similarly, the shearing stress on the right side of the plate is 2 is equal to F2 upon A, that is equal to mu into tau U by tau M. Therefore, F2 is equal to 43.2 newtons. Therefore, total shear force is equal to 43.2 plus 43.2, that is equal to 86.4 newtons. Therefore, in this case, the weight of the plate is acting vertical downward and upward thrust has to be taken into account. So, as it is acting downward, we also must take the upward thrust. Okay. Therefore, upward thrust is equal to weight of the fluid space is equal to weight and density into volume. Therefore, weight density of fluid is equal to rho into weight density of water, that is equal to 9.84 into 0.9 into 1000, that is equal to 9.81 into 900 Newton per meter cube, that is equal to 25.43 Newton. Therefore, net force acting in the downward direction due to the weight of thrust is equal to weight of plate minus thrust, that is equal to 40 minus 25.43, that is equal to 14.57 Newton. Therefore, total force is equal to 86.4 plus 14.57, that is 100.97 Newton. Next problem. A 50 centimeter diameter vertical cylinder rotates concentrically inside another cylinder of diameter 15.10 centimeter. Both the cylinders are 25 centimeter high. The space between the cylinders is filled with a liquid whose viscosity is known. If the torque of 12 Newton meter is required to rotate the inner cylinder at 100 rpm, determine the viscosity of the fluid. So diameter inside is 15 centimeter, outside is 15.10 centimeter, and this go 25 to 10 raised to minus 2 meters, and number of rotations is 100 rpm, and mu equal to how much? Viscosity. We know that mu u equal to pi dn upon 16, that is equal to pi into diameter 15 to 10 raised to minus 2 into 100 divided by 60, that is 0.7854 meters per second. We also know dou equal to mu into dou u upon dou m. Therefore, dou equal to 15.10 minus 15 divided by 2 into 10 raised to minus 2. That is called 0.1 divided by 2 into 10 raised to minus 2. That is equal to 0.0005 meters. Then for dou equal to force upon area, that is equal to mu into dou u by dou y. Therefore, force is equal to torque into, that is equal to force into d by 2. 12 is equal to F into 0.14 divided by 2, that is equal to F is equal to 160 Newton. Area equal to pi dl pi into 0.15 into 25 into 10 raised to minus 2, that is equal to 0.1178 square meters. Then mu equal to force upon area into d dou y by dou u. Force is equal to 160 divided by 0.1178 into dou y by dou equal to 0.005 divided by 0.7854. Mu equal to 0.864 Newton centimeter per square meters. Therefore, mu equal to 8.64 poise. A large plane surface area of 2.4 centimeter apart. Two large surface are of 2.4 centimeter apart. The space between the surface is filled with the glycerin. What force is required to drag a very thin plate of surface area 0.5 square meters between the two large plate surface at speed of 0.6 meters per second? If the thin plate is middle of the two plane surface, the thin plate is at a distance of 0.8 centimeter from one of this plane surface. Take dynamic viscosity of glycerin equal to 8.10 into 10 raised to minus Newton centimeter per square meter. So solution, we can see the figure, that is the height is 2.4 into 10 raised to minus 2 meters, and it is placed at the middle, that is 1.2 into 10 raised to minus 2 from top and 1.2 into 10 raised to minus 2 meters from bottom. Okay, so first when the plate the thin plate is in the middle of the two surfaces. Okay, dou equal to mu into dou u by dou y. Therefore, F1 is equal to shear force on the upper side of the thin plane, that is F1 upon y, that is equal to mu into dou u by dou y. Therefore, F1 is equal to 8.1 into 10 raised to minus 1 into 0.6 into 0.5, that is divided by 1.2 into 10 raised to minus 2, that is 20.25 Newton. Then F2 is equal to shear force on the lower side of the thin plane, that is F2 upon A is equal to mu into dou u by dou y. Therefore, F2 is equal to 8.1 into 10 raised to minus 1 into 0.6 into 0.5 divided by 1.2 into 10 raised to minus 2, that is 20.25 Newton. Therefore, total shear force F is equal to F1 plus F2, that is equal to 20.25 plus 20.24, that is 40.50 Newton. Similarly, when the thin plate is at a distance of 0.8 meters from the one end of the plate surface, therefore F1 is equal to shear force on the upper side of the thin plate. There, that is F1 upon is equal to mu into dou u by dou y, that is 8.1 into 10 raised to minus 1 into 0.6 into 0.5 divided by 1.6 into 10 raised to minus 2. Therefore, F1 is equal to 15.18 Newton. Therefore, F2 is equal to shear force on the lower side of the plate, that is F2 upon A equal to mu into dou u by dou y, that is equal to F2 equal to 8.1 into 10 raised to minus 1 into 0.6 into 0.5 divided by 0.8 into 10 raised to minus 1, that is 30.36. Therefore, total shear force F is equal to F1 plus F2, that is equal to 15.18 plus 30.36, that is 45.54 Newton. Okay. Therefore, I will stop here itself. Then I will go for next one, adhesion and cohesion. Okay.